Okay. So we've been talking about these systems of linear equations. Remember, a system consists of two equations, and the equations have x and y in them. And then what we want to do is solve for x and y, which means that whatever values we get for x and y works in both equations. Okay? But we haven't talked about how to actually solve them yet. The only thing we've done with them is I've given you a word problem, you've created a system out of it, I've given you the answers, and you checked it. Okay? So how do we actually solve these? Well, there's three different ways, one using graphing and two using algebra. And we're going to talk about the graphing one today. Okay? So just as an example, let's say we have a system, two equations. One of the equations is 2x plus y equals -4. And the other equation is y equals x minus 1. And I want to try and find the values for x and y that work in both equations. So that when I go 2 times the x value plus the y value, I get -4. And the y value is going to be the x value minus 1. So to solve it by graphing, here's what we do. We have to graph each equation. So the first thing we're going to do is we are going to graph the equation 2x plus y equals -4. And remember, you've got 3 different ways that you know how to graph. Table of values, find the x and y intercepts, slope intercept. Okay? When an equation looks like this, you can use table of values, you can use slope intercept, but then you're going to have to solve for y first. You're going to have to get y by itself, which you can do. Okay? But let's do this one just for some practice using the intercepts. So I want to find, where does this line cross the x-axis? Do you remember how to find the x-intercept of an equation? Make y equals 0 and figure out what x is. Okay? So we get 2x plus 0, we replace y with 0, equals -4. I can just ignore that. What do I need to do to get x by itself? Divide both sides by 2. So if I do that, I get x equals -2. Plot that. On the x-axis, go to -2. That's one of the points. Now I need to find where is the point on the y-axis, or the y-intercept, and I make x equals 0. So I go back to the equation, and I replace x with 0. So I get 2 times 0 plus y equals -4. Well, 2 times 0 is nothing, so that disappears. So the y-intercept, we don't have to solve it. We just know it's -4. Plot that one. And we've got our 2 lines, or 2 points. We can draw a line through it. Try to make this as straight as possible, because we're going to do something with these graphs after. Okay, so that's one. Let's graph the other one. Y equals x minus 1. Well, we've got y by itself, so why don't we use the slope intercept method? Why don't we use y equals mx plus b? Because that's a quick way to graph. Remember, b in this equation represents the y-intercept. What is the y-intercept if you read it off this equation? -1. What is the slope if you read it off the equation? 1, because there's no number here, we assume it's 1. But remember, I'm going to have to use rise over run, so write it like a fraction. Okay, we're ready to graph. Plot the y-intercept. It's at -1. That's 1 point. To get the second point from the y-intercept, I have to rise +1, so go up, and then run +1, so go to the right. So from here, I have to go 1 up, 1 to the right, and I've got a second point. Okay. If you drew your lines accurately, you should notice they intersect at this point. What coordinate is that? -1, -2. Well, if I take this x and y and I plug it in here, 2 times -1 is -2, right? Plus -2 is -4. So it works in this equation. If I plug it into this equation, is -2 -1 minus 1? Yes. So how do we find the solution? We just find where it intersects. So this is our solution. These are the x and y values that will work in both equations. Okay? And like I said, and I'll just do it down here very quickly. If I check it, 2 times -1 plus -2 equals -4. So it works there. Works in the first equation. And we saw that it worked in the second equation. -2 is equal to -1 minus 1. You don't have to show the check. I'm just showing it to you in this one. You can sort of check it mentally if you want. Okay? But that's how we solve a system by graphing. Graph each equation in the system, find where they intersect. That's your solution. So let's try one more. Let's try example 1. Here we have another system. So we're going to graph each one using a different color. So let's bring up this first one. How would you like to graph it? And it looks like this. Usually intercepts is pretty quick. Because if you think about it, to find the x-intercept, if you make y equals 0, then we get 0 plus y is equal to 8. So the y-intercept is 8. Found it pretty quick. Sorry, I did that. should be x, so we're making y 0. Should be x equals 8. The y-intercept will be 8 too. We can see that in a second. So plot 8 on the x-axis. Find the y-intercept by making x equals 0, and you're going to get the same answer. So we're going to get 0 plus y equals 8. That goes, so y equals 8. Plot that on the y-axis. Draw a line between those 2 points. Where's my root? So I have to get that. Now we got to graph the other one. This one's a little tricky. And the reason is, when I look at this one, I would think, okay, it's set up for the x and y intercepts. The only problem, though, is that I find the x-intercept by making y equals 0, so that disappears. What do I get for an answer? 3x equals 14, so x is equal to 14 over 3, which doesn't divide cleanly, does it? That's really hard to graph. How do you graph 14 over 3? So in this case, normally I would use intercepts, but in this case, I'm going to do the y-intercept. So I'm going to solve for y. So I need to get y by itself. Right now, there's a 3x beside it and a times -2 right beside it. I get rid of what's furthest away first. So to get rid of 3x on this side, subtract it, which means I have to do the same thing to the right side. What does my equation look like after that? Well, I've got -2y still on the left side, and I've got -3x plus 14. Remember, you can't combine these two. They're not like terms. What's the last step to get y by itself? Divide everything by -2. So I get y equals, well, this doesn't divide cleanly, but 2 negatives make a positive. So I can just write 3 over 2x. But this does divide cleanly. What do I get? -7. Now we're in slope-intercept form. Now we're in y equals mx plus b form. What's the y-intercept? -7. What's the slope? So we should be familiar with how to graph that. Plot the y-intercept. Use the slope to count out a second point. Stop a little bit. Okay. So we plot the y-intercept of -7. So we're going down 7. 1, 2, 3, 4, 5, 6, 7. And then from here, use the slope. Rise 3, so up 3. Run 2, so to the right 2. Up 3 to the right 2 puts me here. Draw as straight a line as you can through it. So I draw a line like that. Right here. 8. It's not the 8. All right, so we graph each one. It should be obvious where they intersect if you draw your graphs as accurately as possible, right here. That's going to be the answer. What coordinate is that? Thank you. And that's the answer. And it works. Like, if you look here, 6 plus 2 equals 8. 3 times 6 minus 2 times 2 does equal 14. So it works in both. Okay. So that's how we solve the system by graphing. The only problem is that takes a long time. Algebra is quicker. And we're going to talk about 2 ways we can use algebra to solve these things. But we'll talk about that next week after the test. Okay.